Alright guys, welcome back to Algos Made Simple. If you've got understanding of a linked list, a basic fundamental understanding of how one works, then I believe this is a pretty easy one right here. So let's go ahead and just dive right into it and see how simple we can make the solution. We got Leetcode 19, remove nth node from the end of a list. Given the head of a linked list, remove the nth node from the end of the list and return its head. So I understand that I'm going to be giving the head of a linked list, which of course links to throughout the rest of the list, and I need to remove the nth node, so whatever n gets passed through there, whether it's the third node, fourth node, fifth node, from the end of the list though. So I'm not doing, if it's a 2 passed through at the end, I'm not removing this one, I'm removing this one. So I understand it conceptually. Looking here at the example, again, this actually is n equals 2, so you're removing this 4 from it. And how you would remove that, it's really simple. If you understand linked list, all of these are of course linked by the dot next. So you have 1 right here. This first node right here has a value of 1, and it also has a dot next which links to 2. This 2 has a dot next that links to 3, 3 links to 4, links to 5. So to remove this element or this node, what we need to do is set this link dot next to the 3 to 5 instead. So how are we going to do something like that? Well, what we're going to need to do is utilize pointers, which are kind of a frequent thing in these linked list problems. So let's go ahead and start our game plan here. Pointers, and we will, what we'll want to do is take that in, and we'll want to have that be the separation between the left and the right pointer. So n is separation from left and right pointer. So if we started our left out here at 1, we would want our right to start here at 3, and then we go to 2, 4, 3, 5, and then it's 4 and right's null, so until right's null. But the problem is we end up at that 4, and that's not where we want to be, because yes, that is the node we're trying to get rid of, but we can't do it without updating this dot next on the 3. So what we'll do is we'll have a dummy variable, and that's where we'll start the left at. So we'll still start the right out as at the head plus 2, and we'll have the left start out as a dummy node over here somewhere, and that'll allow our left to end up on this 3 or whatever the problem is, end up at the one where you just got to update the dot next. So our dummy node is of course going to have the list node class properties, which I didn't copy in here, but it's the basic dot val dot next. And we'll set the value equal to 0, and we just want the dot next equal to the head. And I think that's about it for our game plan. One thing to keep in mind, to update these, you have to utilize dot next. To go to the next thing, you have to use dot next. You can't add to the value or add to the index or something like that. You have to utilize the dot next. It's a linked list. So diving in here to the code, we've got remove nth from end, and of course we're getting the head and we're getting n, which n is just a random integer. So we have our dummy variable like we talked about, and again it's list node. We're going to do 0 in head, and then we've got our left pointer, which is going to be set equal to the dummy node. That's where we want it at. We don't want it at the head, we want it at the dummy node. And our right needs to be at the head plus n. So we're at this, if the n was 4, then it would need to be down here at the 5 kind of thing. But again, the way to do that, you can't do head plus n. So we have to set the right equal to the head for now, and then we'll have to come down here and say while n is greater than 0 and the right's not null, then what we'll do is we'll say right equals right dot next. So whatever the next thing is for the right one, so it's at the head. So we'll just go head to here, to here, to here, to here until the n is at 0. And of course we got to bring the n down to 0, so we got to go n minus equals 1. So that'll get our right in the correct position for the starting position. So once we got the correct starting position, it's time to jump in one more loop here, and this is going to go until right equals null. So we'll say while right, and what we'll do here is left equals left dot next, right equals right dot next. and that's going to go until the right is equal to null. So once that right is equal to null, like in this first one right here, the right would equal null right here, our left would be at that 3. So we will be at the number, or at the node we need to be at that we need to update. So once that happens, we're here at the one we got to update. We just simply go left.next, and we don't overwrite it from what it is right now. We don't want it to be linking to that 4. So how can we link it to something? All we have to do is do left.next.next, and that'll link to that 5, or if that 5 wasn't there, it would link it to null, but it would get rid of that node we're trying to get rid of. So then all we have to do is just return this list, and how you return this list? Return dummy.next. And that won't return the dummy node. That will start off with the next, which is the head, and the head will link on through to the remainder of our list. So that's how you get rid of a node in a linked list from the end right there. I think very simplistic, guys. I really enjoy these linked list problems. I think it's a cool kind of format. It's a cool data structure. And I think it's very easy once you have a basic core understanding of these linked lists to really be able to do anything that's asked of you with them. So let's keep at it, guys. We're going to keep grinding and keep knocking these out. So thanks for watching. And if you have any advice or something you would do different or something to make this even simpler or just anything, please let us know. Thanks, guys.